Hi everyone, and welcome to another video of the SAFI webinar series. In this video, we're going to talk about springs. Springs are applied between a joint of a structure and the ground. So, as a joint for a given direction, there can only be one support or spring or imposed displacement. The reaction produced at the spring is directly proportional to its stiffness and the displacement of that joint. There are different types of springs. The regular springs act in compression and tension. We also have compression-only springs, tension-only springs, and we have nonlinear springs. As for the convention, if the displacement of a joint is in the positive x, y, or z direction, the spring will be considered in tension. If the displacement of a joint is in the negative x, y, and z direction, the spring will be considered in compression. Without further ado, let's start our demo. Springs can be defined or edited using the Joint Attributes command. In the Joint Attributes dialog box, we find a tab for springs. We can define springs in translation, so in the direction x, y, and z. We can also define springs in the rotation in the same direction as well. To define a spring, we check the box in the specific direction where we want to add the spring. So, for example, if we want to add a spring in translation in the direction x, we check this box. Then, we specify the type of the spring. We have regular springs, tension-only compression. We also have limited compression and tension springs, and the last option is nonlinear springs. After specifying the type of spring, we need to specify the stiffness of the spring in this field. Then we click OK to validate. It is important to specify only one condition in one direction. So, for this example, in this case, if we go to the Support tab, we can see we restrain the movement in the direction X. In this case, we cannot assign a spring in that specific direction, and we cannot specify or impose a displacement. If we want to activate the spring in the x direction, we need to deactivate the support in the direction x. Then, we activate the spring and we specify the stiffness. Now, if we zoom here, we can see the sign in the software for springs will appear like this in blue, and the spring will appear parallel to the direction where the spring is applied. It is possible to edit springs using selection. Using the Select by Window command, we can select a group of joints, and we can edit the spring condition for the selected joint using the Joint Attributes command. If we want to activate springs for all the selected joints, we can simply check this box and then click OK. Now all these joints will have a spring activated. Now let's see in another example the behavior of springs. In this example, we have a beam that has a fixed condition on the left-hand side. On the right-hand side, we applied a concentrated load. We also added a spring in the y direction. If we edit the joint attributes of this specific joint, and we go to the Springs tab, we can see in this case we have a spring in translation in the y direction. Now let's do the analysis. If we display the graphical results, and specifically the reaction in the y direction, we can see here the reaction at the spring, which is equal to the stiffness multiplied by the displacements. We also have tension-only springs and compression-only springs. In this example, this spring is in compression. If we specify this spring as tension-only, automatically this spring will be deactivated because it is in compression. So, we will specify it as tension only and we click OK. Then we run the analysis again. If we zoom in around the spring, we see this red box with an X inside it. Usually, we see this red box if there is a one-way element that is deactivated in the analysis. In this case, because the spring is defined as tension-only spring, in this specific model, these springs are under compression and the software will deactivate the springs in the analysis, and that's why we see the red box. In this case, if we remove the spring completely, we will obtain the same results because in this case, the spring is already deactivated. We also have springs that act as one-way elements, which are limited to compression and tension. In this case, we need to specify the maximum force that the spring can support. So, the behavior of limited compression springs and limited tension springs are similar to compression-only and tension-only springs. For example, when we have a tension-only spring, the spring acts in tension only. If it becomes in compression, it is deactivated. When we have a limited tension spring, the spring acts normally in compression. If it is in tension, the intensity of the force is limited to the maximum force specified. So, for example, in this case, if we specify this spring as limited compression spring and we specify the maximum force as 1 kilonewton, we then go ahead and click OK. Then we run the analysis again. We can see the reaction of the spring is limited to 1 kilonewton, which is the maximum force that the spring can support. So beyond 1 kilonewton, the spring will be deactivated. Now, the last type of springs that are available in the software are nonlinear springs. So, when we use a nonlinear spring, we need to specify a nonlinear behavior curve. The nonlinear curves define the behavior of nonlinear springs present in the model. Each nonlinear spring must be associated with a valid nonlinear behavior curve. For springs, the behavior curve segment represents the relationship between loads and displacement. The displacements correspond to the local deformations of the springs. If the nonlinear behavior is similar whether the spring is in tension or compression, the option symmetry curve in tension and compression can be checked. As a spring may behave differently in tension or in compression, the user can specify a different force displacement relationship for tension and compression. The values are ordered in growing order, and the forces and displacement values in tension and compression are entered in absolute value. The forces are always positive and the displacements are always positive. So for example, if we specify a curve that is symmetric, we can add here displacements, for example, 1 millimeter, and we'll specify the force, for example, 30 kilonewtons. We can then add another data point, for example, 3 millimeters, and we have 40 kilonewtons. We will have a curve that is nonlinear and we can assign a name to it. Then we can assign it to the spring. Now, when we do the analysis, the multilinear spring will be taken into account. Another thing to keep in mind is negative stiffness, or what we call softening. It is to be used only in the nonlinear analysis, and it may cause the divergence of other analysis methods. That's it for this video about springs. Thank you for watching, and catch you in another one of our webinar series videos.